Okay, now the second factor which I am explaining is electron affinity. The definition I told you, the energy required to draw an electron to the last shell of a neutral atom is called the electron affinity. So as usual, when the atomic number is increasing, the number of electrons or the nuclear charge is also increasing. So when I am going from left to right of a periodic table, see first in this case for beryllium, the number of electrons in the last shell is 2. Whereas when I go to fluorine, the last shell is containing 7 electrons. So the 7 electron power of 7 electrons will be more than the power of 2 electrons in the last shell. The 7 electrons will draw 1 electron very fast because already it has 7 electrons, so it will attract one more electron. It will be very difficult for it to attract one more electron because these electrons will produce a repulsive force not to draw that electron towards itself. Whereas if the number of electrons are less, like in beryllium, there are only 2 electrons. So this will have a tendency to draw another electron or another 2 electron easily. So as I am going across the period, what is happening? The capacity or the tendency of the atom to draw the electron from outside is becoming more and more difficult because the number of electrons in the outside shell is increasing. So it is producing a repulsive force and not allowing the electron to be added. So you need a special or more energy to add that electron to the last shell. So electron affinity increases along a period. Now let's see what is happening when I am going down the group. When I am going down the group again, the atomic radius is increasing, as I told you, it's the same thing, and the nuclear charge is also increasing. So what is happening? The electron affinity should have increased, but what is happening? The atomic radius factor is becoming more dominant than the nuclear charge. So that is why what is happening? The distance from the center to the last shell, the electrostatic force of attraction of the last shell or the last shell is becoming more and more loose. So the electron is more easily added to the last shell as I am coming one by one to the down the group in a periodic table. Have you followed that? So along a period, nuclear charge is increasing, atomic radius is decreasing, so electron affinity is also increasing. Down the group, the atomic radius increases, nuclear charge also increases, but atomic radius is playing a more important factor here, so that the last shell can draw an electron from outside more easily, so the energy required is less. You can note the values here also.